This experimental system determines whether changes in intracellular calcium relate to changes in the lymphatic contractile pattern caused by elevated luminal pressure. First, excise a contractile lymphatic vessel from the rat mesentery and cannulate it on both ends to tightly control the luminal pressure. Next, load the vessel with the ratiometric calcium-sensing dye Fura2AM, which enables the measurement of changes in cytosolic calcium. Using fluorescent microscopy with alternating 340 and 380 nanometer excitation, record changes in lymphatic vessel diameter and cytosolic calcium levels while the vessel is subjected to a luminal pressure step protocol. Also, determine the lymphatic diameter from the time-lapse images obtained. The results indicate a temporal relationship between transient increases in cytosolic calcium and phasic contractions of lymphatic vessels, and a correlation between calcium levels and myogenic constriction.
The main advantage of this technique over existing methods like intravital microscopy is that extrinsic influence on lymphatic pumping, including the rate of lymph formation, neurogenic and endocrine controls, and luminal pressure and flow, are all tightly controlled, allowing a precise study of the signaling pathways that determine the lymphatic contractile cycle.
Visual demonstration of this method is critical, as the isolation and cannulation steps are difficult to learn. The lymphatic vessels are extremely delicate, and poor manipulation can cause them to lose their contractile function.
Mount resistant matched micropipettes in an isolated vessel chamber.